All right, so this is a series of videos that I'm going to take a look at here to kind of help you guys with understanding, what it means to apply the properties of the normal distribution and to find the areas or the probabilities under the normal distribution curve. So I'm going to go back a slide just for a second and kind of make sure we understand here. Right now for this series of videos, we're going to be looking at what's called the z-value. I also call it the z-score. So you might hear me refer to this by accident as the z-score, but it's z-value, and this is a standardized value. You know what's really cool about the z-score is like, let's just real quickly. So we got the ACT, college entrance exam, and we had the SAT, college entrance exam. And let's just choose two random scores. So let's say on the ACT, we made a 21. And let's say on the SAT, we made a 600. And we wanted to know, compared to the population, we wanted to know which test we actually did better on. And so the cool thing about the z-score is what it does is it takes these test scores and it standardizes them. So I'm not going to explain the process, I'll say a little bit about it, but like for example, let's just say that on the ACT, the average score for the population is a 20. And the standard deviation is 2. And I'm completely making these numbers up for discussion purposes. With the SAT, let's just say that the average score is 580, and it has a standard deviation of 35. So with the z-score, what we can do is we can call this our x value. This is the value that we're going to compare. This is the patient in the hospital. This is the height of an individual person that we want to compare to the mean of everybody else. And so with the z-score, what we can do is we can run through here and we can say, okay, for the ACT, so the z-score for the ACT is equal to 21 minus 20 divided by, and that's not working. Sorry about that. Is divided by 2. So that would be 1 over 2, which is equal to 0.5. And then we do our z-score for our SAT. So we say z-score over SAT, and I might need my calculator for this one. We would say 600 minus 580. And you know what? So I don't need my calculator. Let's just change this number to 20 because I'm making this stuff up anyway. So let's change that to 20. Divided by 20. So 600 minus 580, that's 20 over 20, which is equal to 1. Now, at this point, we can compare because we know what the standard normal distribution looks like. We know that on a standard normal distribution curve, going back through our previous video, there it is. We know that on a standard normal distribution curve, we are 1 standard deviation, 2 standard deviations, 3 standard deviations, or -1, -2, -3. And so when we come back to this guy right here, what we see is that on the ACT, we scored a 0.5. We are a standardized score of 0.5. We are half a standard deviation above the mean. So when we draw this out and we take a look at it, here's my mean. Here's +1 standard deviation. Here's +2 standard deviations. Here's +3 standard deviations. And so now I know that for ACT, I'm at half. I'm right here. So this is my ACT. That's at 0.5. All right, and I'll just use, let's see, let's change that color to dark green. Okay, so then I'll change that my SAT is right here. So that's my SAT at 1. So I can see that out of the average, as a standardized situation, I scored better on my my SAT because I have a higher relative position. So that's what's really cool. The z-score is a standardized score. It's a score that allows me to take two different sets of data and standardize them so that I can compare them to one another. So the whole purpose of this video, and I got a little sidetrack there, is to really talk about finding the area to the left of a z-score. That gives you a rough understanding so you can understand what a z-score is. So what we're going to do here is that we are going to try to find the area to the left of the z-score. And there's a process to these problems. And there's a series of 3 videos because we have the area to the left, we have the area to the right, and we have the area between. So here's our hypothetical situation. We have a z-score of 2.09. So remember that if we broke this guy down, like, here would be +1 standard deviation, and maybe right here would be +2 standard deviations. So if I have a z-score of 2.09, I'm a little bit above the 2, but I'm not all the way up to the 3. So I take that z-score, and I want to find the area under this curve. Well, the cool thing about the standardized normal distribution is that I have this thing called table E. And what table E does for me is it allows me to, let me hit pause for just a moment. All right, so let's just jump back so we know right where we were. So here I am, I'm looking at the area to the left. And what I want you to understand is that when you're finding the area to the left of on a normal distribution curve, it's like if we're looking for that area to the left under that z-score of 2.09, then what we do is we go to our table E. So please pay special attention. Older versions of table E might have looked a little bit different, and I'll just say that. Please make sure that you have table E where it's shaded from your z-score to the left, all the way to the left. All right, so if you'll notice right here, we've got our z-scores. All those z-scores right there are negative, so we're on the wrong chart. So we go to the next page. So the opposite page, and you'll notice that this is all the positive. Now what I want you to see is, think about the correlation here. Think about the correlation that we are looking at the positive z-scores, and it's showing area all the way into the positive standard deviations. Whereas this guy has all negative z-scores, and we're on the left of the mean. That means we're less than the mean. That means we have all negative standard deviations. So just want to make sure that point that out. And as you start applying it and utilizing it, it'll start to make more sense. All right, so our z-score we were looking for was, what, 2.09? So we cruise down right here. We find 2.0. There it is. Take a piece of paper, something like that. Mark yourself a line going across. Now, our number, like I said, was 2.09. So the part that we have right now is we have the 2.0 part. So I still need to take care of this 9 part. So we come back and we come across the top. So that would be 2.00, that'd be 2.01, 2.02, so forth and so on to 2.09. And there's my score. So the area under the normal distribution curve for a z-score of 2.09 is 0.9817, or also known as, also known as 98.17%. Because remember, the change a decimal to a percent, you move that decimal 2 places to the right. So that's our answer. And this concludes the video for how we use table E to find the area under the normal distribution curve for a z-score. Okay, and the same thing would apply for a negative. So you just use this video to go practice some more problems like this.